All right, guys, this is Mr. Shermack here, taking a look at our weight and mass calculations practice worksheet. I've done 1, 2, and 3 for you already. Here is the work, here's the answers. You can pause the video to check your work and see if you have similar answers. Um, Take a note that your answers are going to be different based on your x value. I'm going to be solving these questions with the x value of 2. Okay, so here's the work for 1, 2, and 3. But I will walk you through the steps for questions 6, 7, and 8 on the back side here. And so that's what we're going to do right now. All right, so let's take a look at number 6. It says a chinchilla has a weight of 4 times x to the newtons. The chinchilla is sliding across a frictionless ice at a constant velocity. Okay, couple things to underline here. Frictionless, and constant velocity. All right, that's going to help me with my free body diagram. All right, before I go any further, let's figure out the weight of this chinchilla. Right, so we're going to go 4 times 2, which is going to equal 8 newtons. All right, so draw a force diagram for the chinchilla. So the chinchilla is on a stable surface, right? So we know there's gravity coming down. And since it is a stable surface, we're going to have a arrow going upward for normal force, right? And both of these arrows are the same size, so that means the forces are balanced here, okay? All right, so we did part A. How about part B? What is the mass of the chinchilla? Show all work. All right, well, to find the mass of the chinchilla, we're going to need this equation. The force of gravity equals mass times gravity, right? And we know that gravity equals 9.8 newtons per kilogram. All right, so to find the mass of the chinchilla, let's plug in our variables. We know that the weight of the chinchilla is 8 newtons. We do not know mass, but we do know the gravitational pull, which is 9.8 newtons per kilogram. All right. So to solve for mass, all we're going to do is rearrange this equation and divide by 9.8. So we'll do 8 newtons divided by 9.8 newtons per kilogram, and that will give us the mass, right? When we do that, our unit should be kilograms, and so just divide 8 newtons by 9.8, and that'll give you the kilograms, the mass of the chinchilla in kilograms, okay? So I can do that for you real quick. We do 8 divided by 9.8. We get 0.812. So 0.812. All right, that's number 6. Let's move on to number 7. Mr. Wise is speeding up his video game collection by pulling it with a string to the right. The collection has a mass of 2 times 2 kilograms. So they're giving us the mass here. So the mass of this video game collection is 4 kilograms. All right, before we go any further, let's draw a free body diagram of this video collection. All right, so here's the video game collection. We know gravity's pulling down, the normal force is going up. Mr. Wise is pulling the string to the right, so that is this way. So we call that the tension force. And let's see, do we have any clues in here? Oh, yeah, Mr. Wise is speeding up his video game collection, right? So that means that this tension arrow needs to be larger than my friction arrow that's going to the left, right? Friction always goes in the opposite direction of motion, right? So if our video game collection is going to the right, friction is going to the left, all right? So we have unbalanced forces here because this object is speeding up. All right. Next step is to calculate the weight of the video game collection. So we're going to use times G. All right. The weight force, Fg, is going to equal mass, which is 4 kilograms, times gravity, which is 9.8 newtons per kilogram. All we need to do is multiply 4 times 9.8, and that'll give us 39.2 newtons. So the weight of this video game collection due to gravity is 39.2 newtons. All right, last one here, looking at number 8. We have the 100 times x kilogram giraffe is driving to the left on the moon and suddenly steps on the brakes. I didn't know giraffes can drive. I didn't know they had giraffes on the moon, but that's pretty cool. Let's figure out our kilograms here. So 100 times 2 equals 200 kilogram giraffe is driving to the left on the moon and suddenly steps on the brakes. All right, so let's draw a free body diagram before we talk about part B here. So we have gravity. There is gravity on the moon. It's weaker than the Earth. As you can see, if we just fast forward here, the force of gravity on the moon is 1.6 newtons per kilogram, so it's less than Earth, which is 9.8, which is why you can jump higher on the moon. All right. So we have gravity going down. Oops. Normal force going up. And we are going to have, let's see, I don't see anything in the problem about the engine applying a force. The only thing I see is brakes. So that means the force of friction is in place, going to the right. Okay. And the reason friction is going to the right is because the giraffe is driving to the left, right? So friction is going the opposite direction of motion. All right, last part here. Let's look at part B. What is the weight of the giraffe? Gravity on the moon is different, and it is 1.6 newtons per kilogram. All right, so we're going to use the same equation. Fg equals mass times g. All right, so we know the mass of the giraffe is 200 kilograms. And we also know the gravitational pull is 1.6 newtons per kilogram. So all we need to do is multiply those two together to get the force of the gravitational force of this giraffe. We do 200 times 1.6, and you get 320 newtons. All right, I hope that was helpful. Oh, before we conclude, we forgot to identify that this is unbalanced here. All right, guys, I hope that was helpful. If you have any questions, let's talk it out in class. Have a great day, and thanks for watching.